My name is Jason Vaughn Holmes. In this video, I am demonstrating a simulated insider breach for CMIT 421 Project 2. I will use Parrot Security OS as the insider machine and Ubuntu as the victim machine. I will show scanning, directory enumeration, exposed test credit card data, Wireshark capture evidence, Apache log evidence, and remediation recommendations. So let's begin with Parrot first. I'm going to run a script to confirm the IP address of the Parrot Insider machine in this lab. So Parrot is using IP address 10.1.4.27. So we're going to type in the script, as you can see. And to confirm what I said earlier, the IP address is 10.1.4.27. So now we're going to go over to our victim machine and we're going to run the same script to check the IP. And as you can see, the Ubuntu victim machine is using IP address 10.1.4.200. Both systems are on the same internal lab network, which allows the insider machine to communicate with the victim machine. So now going back to Patriot, we're going to run another script to ping that the Patriot machine can reach the victim machine over the network. So we're going to type in my script. And as you can see, we get a return showing the IP address for the victim machine, which is 10.1.4.200. So we have confirmed that the Patriot machine is able to communicate with the victim machine. So now we're going to go over to our victim machine and we're going to confirm that Apache is running. So I'm going to input a script. So we confirm, and we're going to type in our password. You can't see the password. So as you can see, it says right here, active running. So we have confirmed that Apache is active and running on the Ubuntu victim machine. This means the victim has a live web service available on the internal network. So we're gonna exit this by pressing Q. So let's go back to the Patriot. So from the Patriot, I can reach the Ubuntu Apache web server. This confirms that the web server is accessible before I begin scanning. Now, how we confirm that is we're going to input another script. And it shows right here because it says okay. So that shows that we are able to access the web server. And to show you another way to confirm, we're going to open Firefox and we're going to type in we're going to put in HTTP, the IP of the victim, which is 10.1.4.200. Press enter. And right there, this shows us that we are able to, that we are on the server. All right. So briefly, I'm going to show you that we already have Wireshark running on our victim machine. Now, the Wireshark is already running on our Ubuntu victim machine and capturing traffic on the ENS33 interface. I will use it later to show packet level evidence of the Nmap and the keto scans. So going back to our Parrot, excuse me. So now we're going to run the Nmap scan. First, I'm going to do a timestamp, type in date, so you can see the date and time that we're running this scan. And then we're going to input our script. As you can see, it says that the scan is starting. So we're starting the in-map scan. So I am now running an in-map scan against the victim machine. The purpose of this scan is to identify exposed services. In this case, I'm focusing on port 80 because the victim is running an Apache web server. So as you can see from the results, the in-map results confirm that port 80 is open and that Apache is running on the victim machine. This represents the reconnaissance stage of the breach simulation. So now we're going to run another script. We're going to run a Nikito scan. And once again, type in date so we can get another timestamp. We're gonna run our script for the Nikito scan. So next, I'm running Nikito against the Apache web server. Nikito checks for common web server vulnerabilities and misconfigurations. So give us a moment and we'll get the results. All right, so as you can see, our results are telling us that the Nikito scan identifies the web server issues and points to the exposed backup directory. This is important because backup folders should not be publicly accessible through a web server. So now we're going to run a dirb, which is a directory enumeration. So once again, we're going to type in date for a timestamp. Then we're going to input our script. All right. So now I am using dirb to enumerate directories on the victim web server. Directory enumeration is used to find hidden or unlinked web directories that may not be visible from the main website. So as you can see from our results, um, dirb discovered the backup directory and showed that the directory is listable. This is a serious issue because directory listing can expose files that were not meant to be viewed by users. So what we're going to do now, so as you can see right here, it shows us the directory. As you can see, it says http colon // 10.1.4.200 / backup /. So that is a directory that you don't want to be public, but we're about to go to it. So we can go back to Firefox, and we're gonna paste in the link. And as you can see, so after discovering the backup directory, I open it in the browser. The discovery listing shows a file named backup.html. In a real environment, this would be a major warning sign because backup folders should not be exposed through the web path. So we're gonna go now. We're gonna open that file. So so after opening, it reveals that this is test credit card numbers with my name visible on the page, like, as you can see, Jason Von Holmes. This is Simulated lab data only. This is not real. But if this were real customer payment data, it would represent a serious data exposure and possible breach. So now we're going to go back to our victim machine. So now we're back on our victim machine, and right now I'm showing you Wireshark, right? And Wireshark pretty much captures all like the traffic that's been going on from the Patriot side. I mean, Parrot side, excuse me. So what we're gonna do, we're gonna go to this bar right here, and we're gonna filter out the scans that we did on the Parrot side. So I'm gonna type in frame contains in map, enter. So as you can see, Wireshark captured the nmap traffic from the Parrot inside a machine to the Ubuntu victim machine. This gives packet level evidence that reconnaissance activity occurred. So now we're gonna go back to our search bar and we're gonna filter out the Nikito scan. Let's enter again. So Wireshark also captured the Keto traffic between the Parrot machine and the Ubuntu victim. This confirms that the web vulnerability scan was visible at the network level. So now we're going to go to our terminal on the victim machine, and we're going to run another script to review the Apache access log. So now we are reviewing the Apache access log on the Ubuntu victim machine. These logs provide host-based evidence of the web activity that occurred during the breach simulation. So now we're going to run another script to look at the in-app related activity. So this script or command filters the Apache log for in-map related activity. So now we're going to do another script to filter for Nikito related activity. And as you see, once again, the command shows the Nikito related activity in the Apache logs. So now we're going to run another script to show the DERB enumeration activity against the web server. So input our script, enter, and there you have it. This is the DERB enumeration activity that happened against the web server. So now we're gonna confirm that the backup directory and the backup HTML file were accessed through the web server. So we're gonna input the script, enter, and we're gonna input our second script, our command. So by filtering the Patriot IP address, which is, remember, the Parrot IP is 10.1.4.27. That is this one. But we was able to filter it out through Apache. So filtering by the Parrot IP address ties the activity back to the insider machine at 10.1.4.27. This connects the scanning, enumeration, and the backup file access to the same source system. In summary, the simulated insider machine scanned the Ubuntu victim, identified the Apache web server, discovered the exposed backup directory, and accessed a file containing test credit card data. The activity was captured in Wireshark and confirmed through Apache access logs. The biggest issue was not just the scanning activity. The bigger issue was that sensitive test data was stored in a web accessible backup folder with directory listing enabled. So, how can we fix this, right? To reduce the risk, the organization should remove sensitive files from web accessible directories, disable directory listing, restrict access to backup folders, improve Apache log monitoring, and use IDS or IPS tools to detect scanning and enumeration activity. The organization should also alert on suspicious user agents and repeated directory enumeration attempts. Even though this lab used test data, exposed payment information should still be handled seriously through responsible disclosure procedures. This concludes my CMIT 421 Project 2 breach demonstration. Thank you for watching.